Okay, I make it 9 o'clock, and I can see the lady outside the door looking as if she's going to close the door in on us, so I guess that means it's time to start. Welcome to the last day of the conference. This is session M31. This is a repeat of a session that we ran earlier this week. It's on WebSphere MQ Security. We're going to talk about the range of features for security that MQ has. And I wanted to focus mainly on the new stuff that is out in version 7.1, because I suspect you're all interested to hear what's new. But I will set it in context with all the other things that are there, but just talk very briefly about the things that are not new. In the notes, in the PDF that you can download from the website, there will be a lot of things that I'm not covering today that were pre-existing prior to 7.1. So if you are new to MQ, and you're not just here to hear about the new things, there is also a lot of notes for you to read that we won't have time to cover this morning. So I'm Morag Hughson. I'm here today to talk to you about it from the Hersley lab in the UK, where we make MQ. If my accent is such that you have difficulty understanding me, please just wave at me and tell me to repeat things or to slow down or whatever. So we're going to look at MQ, and we've broken it down into the sort of classic set of areas that often one sees security spoken about in. We'll define what these terms are first, and then we'll go through them all. Now, if you come to the original session earlier this week, I would have told you come and play with it in the lab tomorrow. However, this is Friday, and the lab has already been, so you can't come and play with it in the lab on Wednesday. However, the scripts and the instructions for the lab are at that link. Now that link is not in the PDF, so if you want to take a note of it now, the image for the lab, the actual VMware image, won't be there, but if you want to play with 7.1, get yourself a trial edition, or indeed if you've got 7.1 in the house, you can then play with it. You can use the scripts from the lab and the instructions to have a go when you get home. So, moving on. So what do we mean by identification? We mean the way you identify a user of a system or an application of a system in a unique manner. Okay? The identity of that user. Not to be confused with authentication, which is proving that assertion of identity. So if I were to say my name is Bob, you would all go, yeah, prove it. And I'd get my passport out, and sure enough my passport would say Morag. And so I could not authenticate my assertion of being called Bob. So authentication is proving the assertion of identity. So the two are often covered hand in hand, because really one without the other is no use. Access control is the term we use when we're talking about limiting access to only authorized users. Now this can be limiting access to a resource, or limiting access to only certain operations on a particular resource. So I could be allowed to do things to Q1, or more specifically, I could be allowed to create Q1 and delete Q1. Okay, so I can have specific operations or access across that resource. Auditing is a term I suspect you're all familiar with, tracking who has done what, to whom, and when. Confidentiality usually results in an encryption algorithm being applied to something. It is protecting sensitive data from unauthorized disclosure, preventing people snooping on your information. Data integrity, being able to detect whether your data has been changed by some means, either through a deliberate malicious attack, a hacker, or through some accidental error, a transmission error, a hardware fault, something like that. Either way, you want to know if your data has been changed in transit, and a data integrity service of some sort, such as a digital signature, would allow the detection of that. And finally, non-repudiation is the term that we use to talk about when you want to prove that somebody said something later. So let's imagine I sent a message that said, move 2 million euros from this bank account to another bank account, and that was acted upon, and then later the sender came in and said, I never told you to do that. Non-repudiation is the term that reflects on the manner by which you can prove it. It involves being able to initially prove the message came from that sender, so a digital signature, for example, and then additionally a non-tamperable long-term storage of that message that you can then retrieve later and go, yes, you did, here's the proof. It's a very difficult task to cover. It's not something we have a solution for today, but it is the sort of thing that is done at an end-to-end sort of position as well. But I include it here for completeness. Won't be talking about it any further today. So, MQ Security then. We'll go through each of them as we take them in turn. We start with identification. MQ uses OS user IDs for identification. You will see these OS user IDs showing up in something we call message context. Message context is a certain set of fields within your MQ message descriptor, your control information on the head of your messages. We have identity context, which contains that user identifier, also a counting token and a free format field for your use. And we have origin context, which usually reflects the last footer. So if your message is hopping through a number of things, origin is usually the last movement with the description of the application that did that movement. But the user identifier here, this is your OS user identifier that is part of your identity context and moves with the message as it transfers through the system. We'll come to link level later. We'll do a whole section on link level at the second half of this session. Authentication. We, at local bindings, rely on the OS to log on to your system. OS user ID and password is authentication for your local bindings applications. But there's also a feature in MQCONNX that is suitable for using for authentication as well. There is a structure that you can use called the Connection Security Parameter, CSP, where you can provide user identifier and password and send that across to the queue manager by attaching that structure to your CNO and making your MQCONNX. This is available for local bindings and if you wish for a client attachment too. It's passed to the OIM on the distributed queue manager where there is a plug point that you as a user can write to do a user ID password lookup or buy such a thing from a vendor or whatever as well. Yes, question? The OAM is the Object Authority Manager. It's think of it as the security access control component of MQ. It does the same job as, let's say, RACF does on ZOS. It is the component that does access control and now a little bit of authentication as well. Okay. We'll talk a little bit about it later as well, so I apologise for introducing a term before I have described it. Also, if you are doing this as a client, and a word of warning, you would want to have some form of encryption since you are sending a password across a network. Then this password and user ID will be passed to the security exit on both ZOS and distributed, allowing you to do, again, some form of lookup and perhaps setting of MCA user in the process. And there are a number of vendor and as-is examples of that you can get hold of. And again, we will look at link level considerations, so clients and channels, a little bit later. Access control then. So this is controlling who has authority to do things to particular resources. We have two equivalent mechanisms. On ZOS, we are lucky enough to have an external security manager. A choice of three that I know of that are SAF compliant, the RACF, ACF2 and Top Secret. MQ is happy to use any SAF compliant external security manager to do access control on our behalf. On the distributed platforms, we are not lucky enough to have a platform-wide external security manager to use on the Unixes and Windows and so forth, so we wrote our own, and that is the Object Authority Manager. That does that same job. Both of them provide the concept of profiles and accesses to those profiles to control operations that you do on MQ resources. Those operations may be administrative operations, such as creation and deletion of queues and topics and channels and so forth, or they may be applications working with those objects, opening a queue to put messages to it, to get messages from it, inquiring objects, that kind of thing. So these two equivalent mechanisms control our access control to MQ resources. So when you administer MQ, first of all, you have a number of control commands. For example, create MQM, set MQAuth. These are controlled by MQM group membership and various OS facilities to lock down access to those. But you also have MQ commands, your MQCPCF commands, so define queue, delete channel, that kind of thing. You can issue those commands, for example, from run MQSC, but you still need to control the access to them. Okay, many people set their run MQSC so that it does not require MQM group membership in order to run that control command. So you must secure the actual MQ commands so that people can only do what they're allowed to do. Because, of course, there are many other ways to issue commands against your MQ manager, your Explorer, ops and controls panels, CSQ util programs, or indeed any user-written application that sends a message to the command queue can issue a command. So we need to do more than just control run MQSC. In order to secure access to your MQ commands, there are a number of tools you can use. One of them is set MQAuth, which I'm sure some of you are familiar with. It allows you to grant access to do a particular operation. There is an equivalent to set MQAuth in the Explorer, the Authorities wizard. Object authorities manage authority records, and you get a display such as this, allowing you to choose the particular operations this user ID or group is allowed to do. New in version 7.1, there is now also MQSC versions of set MQAuth. Set authreq is the MQSC command on the distributed platforms. Something like this, set authreq profile app1 ***, so any profile starting with app1, object type queue, the group is group 1, and I'm going to add the authorities put, get, and inquire in this case. This now means that if you're making a save queue manager script, a script that contains all your object definitions for replay if you need to rebuild a queue manager, or for cloning if you're making a new one looking the same, you can have your authreq commands in the same script as your object definitions. So define queue, grant access to queue. Next, define channel, etc., etc. So very handy there, being able to reduce the number of different scripts that you have to manage. There is also a new wizard that was actually delivered as support pack MD05 in the interim until we came out with 7.1 because we wanted to send it out early. Explorer wizard, you get at it from your context menu on your queue manager, object authorities, add role-based authorities, and it is a simple one-click, or well, not very many clicks, wizard to allow you to grant read-only access to all your objects, which may be very useful if you want to set up users that are going to look at things but are not allowed to touch things. Or full administrative access. You have the option to allow browsing of messages on either selection. And if you were to scroll this down, which I can't today because it's PowerPoint, the last two set up the access you need for Explorer and its reply queue. So it is designed for allowing access through Explorer. This bottom pane here is cut and pastable, so you can copy what we have created there to put it into your own scripts as well. And maybe you take off processes and channels because you don't need them, for example, so you can edit it. But it's a quicker way than typing in the 15 or so commands that you might otherwise need, is the idea. Yes?
Will there be an update of the Safe Queue Manager to also get all this authentication, authorization information?
So, question, is Save Queue Manager going to be updated to cover all this? Save Queue Manager has been pulled into the product. So at 7.1, there is a dump MQConfig control command, which does the job that SafeQManager did, because the author would like to retire. And it is not going to be backported to earlier releases, because we have done it in a manner by means we do not have to ever touch it again. We've brought it in, we've tied it up with the internal code, so any time a command changes, the dump MQConfig is automatically updated. So it doesn't then have an additional, every release we must do this. We've done it so that it's come for free for now on, and it does have off-rec MQC commands as part of the output, all in the same script. Okay? So, that was admin and securing that, and also we'll look at access control when you're using the API. Now here's a section that's very much, you can read it later. Lots of C notes for references. I don't like deleting stuff from presentations, and I've previously made it, so my presentations just gradually get bigger and bigger and bigger. We're going to look at a couple of the most interesting ones. I suspect queues and topics are the ones you're always more interested in access control for, so we'll talk about those. We'll start with opening a queue. The main thing to remember about access control when you're opening a queue is that it is the named resource that is checked. So if you're opening an alias queue, you don't have access to the base queue, but the check is done on the alias queue. It's a good way of having a facade against a base queue so no one can really get at the actual base queue. There are a number of exceptions. I'm not going to read them because you guys can read as well as I can, and I don't like presenters that read their foils. I am going to talk about the bottom two, however, because they are new in 7.1. So we've got another foil that walks through this. So let's look at cluster queue security. When you have cluster queue hosted locally, the access check is on the named queue profile. Yep, that's right, that's what I said before. We look at the access control for the named profile. Good. If it's hosted remotely, now in 7.1, we do the access check on the named queue profile. So now, in 7.1, it doesn't matter whether your queue is hosted locally or remotely for the access control check that's going to be done. This is a change. Previously, if your cluster queue was hosted remotely, then the check was on the system cluster transmit queue. This was problematic because if I had been granted access to the system cluster transmit queue so that I can use Q1, it also meant I can use Q2, Q3, the system admin command queue, etc. Until perhaps security was added at this end to stop me. So, this is a better model, doing it on the named queue profile. This is the model that is already there on ZOS. ZOS has no requirement for an object to exist in MQ in order to check a profile. It doesn't care. The profiles belong to Raquel. In the OM, previously, there was a rule that we have now got rid of that said that an object must exist to have a profile. Now, an object does not have to exist in order to have a profile. So you can have a profile on QManager1 for Q1, even though Q1 does not exist. Now, much as I would like to move you all over to this new and much more granular security method as soon as you install 7.1, you would tell me that was wrong because first you have to do a whole lot of profile setup to work with that scheme. So by default, you will continue to use the system cluster transmit queue until you change cluster queue access control in your qm.ini file. Okay. I'd encourage you to do this, but at least you don't have to do it at the same time as upgrading your installation to 7.1. Get that out of the way first and then look at changing your model over. Now there's another part to this as well. If you do a fully qualified open of a queue, so when you programmatically say open queue on QM2 very specifically, then the check is done on the named queue manager profile. And again, that is designed to match the way ZOS does this. And this is also new in 7.1. Previously, this check would also have been done on the system cluster transmit queue. This is controlled by the same cluster queue access control QMini. Yes, T.Rob?
The bullet there says fully qualified cluster queue, but I think it means queue that resolves through the cluster, because if you had, for example, a dynamic queue that's not advertised, this would work there too, correct?
That's correct. It's when clustering is used to resolve the path to that queue manager. So if I said system cluster command queue on QM2, and that was resolved using cluster channels to get to QM2, the access control would previously have been on system cluster transmit queue and now is on the remote queue manager name profile. So essentially anything that used to check system cluster transmit queue pre 7.1 has now changed to check something different. Either the named queue, if you're not specifying queue manager name, or this new type of profile, if you are. Now, this new type of profile has a type RQM name, so set MQAuth -T RQM name -N, the name of that remote queue manager, or there's another example of your MQSC version of the same. And this is again done to match the way ZOS does this. So it's a much more granular, better control for you. You now don't have to give people access to the system cluster transmit queue. So those of you who have struggled in the past, have a layer of alias queues to get around this, they can now go. Slim things down a bit. So that's queues. Any questions on that before we move on? Feel free to jump in whenever you want. If I'm not making something completely clear, ask questions. I go home after today, and then you have much more difficulty in asking the questions than you do while you're here. That's the purpose of coming, right? So, topic security then. When you have an application that does an MQ open to a topic in order to publish, or an MQ subscribe, MQ sub, in order to subscribe to a topic, there is also an access check. So this application is subscribing to the string price/fruit/apples, which is price/fruit/apples. That is this node here. Now, when we do an access control check on a topic, we start at the node here and we say, is there a profile at apples? No. In order to have a profile, we need a topic object that is referencing that node. So we walk up the tree. Is there a profile for fruit? Yes, we have a topic object defining fruit. We can have a profile hung off that point. Does that grant my user access to fruit? If the answer is yes, then great. We return code OK. If not, we carry on up the tree. Is there a node at price? No. Finally, we will check against the very root, if you like, of the tree, against the profile for system-based topic. Is there permissions at system-based topic? If the answer finally is yes, then that's okay. If the answer is no and we have reached the top, then we will return not authorized to the application. So why is this? Well, imagine that I have made the subscription and I do not have access here. If we were to take the lack of access to be a denial, and bear in mind MQ has a permit model, not a deny model. If we were to take the lack of access as a denial, but I had access at the top, I could just remake my subscription at price/wildcard and still get the same messages, so there'd be very little point. So what we say is, make your security for your topic tree at a particular layer. So I've picked this layer here and put all my security on this. It's less confusing than having some above, some below, different things. Which one is it? Pick a layer, perhaps not the lowest layer, because you might have application-defined leaves at the bottom of your topic tree, and do your security at a consistent layer. Security will be checked, as we said, on sub and open or put 1, but also if you do an MQ close to remove a subscription that you didn't originally open, we'll also do a security check, similar to closing a dynamic queue that you didn't create. There'll be a security check. There may be more than one check, and thus there may be more than one failed check. We'll look at authority events in a moment, but their authority event may report you several topic objects in the failure for a subscription or an open of a topic, and your RACF messages may report more than one ICH 401 failure as well. That is by design. Additionally, if you decide not to use MQSO managed, which tells the queue manager to look after your publications for you, and instead provide a particular queue for that purpose. In this case, I've got Q1, I want it for my subscription queue. We additionally do a check that you are allowed to put to that queue. Now, your application is not going to be putting to that queue, but your application is causing that queue to fill with messages. So the appropriate check for that does seem put is an appropriate one. So if you are not allowed to cause that queue to fill with messages, you will not be allowed to subscribe, and again you will fail on the second step. That is not checked if you use SO Manage, because then the queue manager is looking after your queue for you. So that's access control. Again, there's a few considerations for channels that we will look at later. Auditing. Now again, on the ZOS platform, we're very lucky. We have an external security manager there. That external security manager manages the profiles for us, and you can configure your favorite external security manager to report failed accesses, for example. When somebody tries to access a resource and they're not granted authority, you can have an audit trail for that. If you wish, you can have an audit trail of successful accesses to your profiles as well. That may be a rather larger audit trail. And you also get an audit trail for changes to the security profiles and any changes to the accesses on those security profiles. On the distributed platforms, we have no such luxury, so MQ writes its own authority events. And there are 6 types. If you fail to connect to the queue manager because you're not authorized, you get a type 1. If you fail to open or put on a queue or an object of any sort, in fact, you'll get a type 2, telling you the resource you tried to open, the user ID, the open options you've used, so you can tell was it put that failed, was it get that failed, which of these intents that were reported on MQ Open were you not allowed to do. MQ Close, for deletion of dynamic queues or deletion of durable subscriptions that were not your own. You have a security check. If you fail those, you'll get a type 3. Issuance of any command that then fails on the security check, you'll get a type 4 report. And a sub-failure will have one of the last 2, type 5 if it's the topic check that you failed, and a type 6 if it's that destination put check that you failed. Yes, question?
Are those dynamic queues are our requests or our responses?
Sorry, can you repeat that?
For deletion of dynamic queues we mentioned for the MQ clause, is it the return that the message queue provides the answer? Those are those the dynamic?
Those are the dynamic queues. Yeah. Dynamic queues are the ones you create when you open a model and you get back a temporary or a permanent dynamic queue. If it's a permanent dynamic queue, it stays around until you do a close delete. Whereas a temporary dynamic queue, as soon as you close it, it's gone. So permanent dynamic queue is a specific type of these model queues that you open to create a temporary. If somebody else, not the original creator, does a close with the option that says delete on one of these permanent dynamic queues, so yes, you're right, used for reply queues, that kind of thing, then you have a security check and the possibility of a failure and doesn't event. Okay, so that's auditing. Very briefly, application level security, and this is a recognition that a message, you have your control information, you also have your application data. And this application data is yours, okay? It could be anything from the bus timetable to a bunch of credit card numbers and some financial information that's very important. Clearly, the application of something like encryption on that is going to vary in need. Some things you don't mind who can see it, other things it is absolutely required by law that somebody has it protected. Okay? So there's a massive variance on which messages you would want to apply such things to. And we have the concept of what we call application level security, which is when security services are applied before a message even leaves the application process. So a service such as encryption or data integrity with a digital signature, something like that. Before the message even leaves the application process, this security service has been applied to it and is thus there, encrypted, let's say, while at rest on a queue, like a transmit queue, or a target queue waiting to be retrieved. And again, the security service is not unapplied, if you like, decrypted, until it is into the application process again. So there may be a number of hops through a number of queue managers, and that service doesn't need to be applied and unapplied at each hop like it would be with what we call link level security, which is this portion here. Now again, I'm going to tell you about a session you have missed, but you may be interested in grabbing the PDF to read about it. We had a whole session on advanced message security, which is the product we have in the MQ family that does this application level or end-to-end level security, allowing you to apply encryption or data integrity methods to your messages before they even land on the queue. So if you're interested in that, grab the PDF. The author's email address will be on the cover, and you can send him questions next week. We are going to look at link level security now. And link level is this set of security services. So security services that are applied before the message goes out onto the network, which is by far the scariest part of your moving of messages from one place to the other. So for some businesses, link level security is enough. For other businesses, application level security is a requirement. So, identification at link level. So when messages move over channels, we have message context. As we said before, user ID is inside the message. This may lead to issues if you wish to use that user ID on another system where it is not defined or not even recognized. For example, the 13-character administrator user identifier doesn't go down well in your RACF 8-character database. So there's mappings or translations of message context that you might wish to do if you're going to actually make use of the user ID inside the message. And then we have security exits, as we have for many years, and something new, channel authentication records, that can set the identity of a particular channel or client when it's running in the server. Security exits can do an indefinite exchange of any arbitrary means at all to interrogate the partner. Useful when you want to do something extremely explicit, something that is not built into the product. No defined format, you don't need to be doing comms programming. You send the buffer to the channel and it will move it to the other security exit. And this interrogation can go on until the exit decides that this channel is allowed to run and might set the MCA user accordingly, or that this channel is not allowed to run and will end the channel. Security exits are still there in 7.1, but we hope that maybe some of the security exits you use might now be replaceable by this new thing in 7.1 that we call channel authentication records. These are an artifact in MQ that allow you to set rules on how inbound connections are going to be treated. Now these may be inbound clients, inbound queue manager to queue manager connections, or other rogue connections that are coming in and causing that bad data received FTC. Like if you point your browser at your MQ listener, you will generate an FTC with whatever the browser sent. The rules can be set to allow a connection to come in, to block a connection, to allow a connection in and assign it a particular MCA user to run under, to ban privileged access. Privileged access is my term for MQM group access on all the different platforms. To provide multiple different positive or negative SSL peer name matching. So no longer do you just have that one field on the channel, you can now make multiple rules applying to the same channel with differing SSL peer name patterns.
What is FTC?
An FTC is a file that has been cut when something bad happened. Okay, so it's our way of recording the first failure data capture, which is FTC, for that problem. And there are some FTCs that are working as designed, and one of them is if you point something that isn't an MQ channel at an MQ listener, then you will get an FTC. So you can tell which other thing was misconfigured to point at this port by looking at the sort of data. Was it HTTP or something like that? You can perhaps help diagnose that. And these rules can be built using a number of the identifying characteristics of an inbound connection. For example, its IP address, its SSL distinguished name, and the certificate supplied, the client asserted user ID, or the remote queue manager name. So these are the characteristics we can pull from in order to identify and decide whether we like the look of a particular inbound connection. Now, in order for an inbound connection to get through into your system, I would like to remind you that your IP firewall is still your first port of control. And this feature in MQ is not trying to get rid of that. It does a very good job of blocking rogue connections and saving you from denial of service attacks and so forth. So this is still your first port of control. If you get through the IP firewall, there is a new feature that is on the listener. So before we even know what channel this is, we do have a rule that we can apply to block particular IP addresses. This is not a replacement for your IP firewall, but it is there for a specific use case. Imagine Friday afternoon, after coming back from the pub, let's say, application writer makes small change to application and deploys it to the production system and goes home before realizing he mistyped the name of the channel he's going to use. And all weekend, this channel has been trying to connect in and complaining and cutting an FTC that this channel name doesn't exist. And the administrators over the weekend are tearing their hair out, want to get hold of this guy and shake him warmly by the throat. This listener blocking area is for those kinds of things where you have a temporary need to block something that if you put it in the firewall, the process for getting it in the firewall and then getting it out of the firewall again is perhaps too heavyweight. You just want a quick place in MQ control that you can put this for a couple of days till you get this sorted out. That's the purpose of it. We hope it will be a short list. If it's a long list, and that long list is always the same list for weeks and months on end, that says your IP firewall probably should have had the updates and not this. But it's there for those kinds of cases. It is blocked before we read any data, so we don't know what the channel name is. It's all done just on IP address. And in order to protect our listener from a busy reconnect loop where a client comes in, gets blocked and immediately tries again and immediately tries again, we have a very simplistic hold of that blocked connection for 30 seconds before we let it go and say we didn't line you in, just to save us from that kind of busy loop denial of service. But still your IP firewall is far better at doing denial of service protection than we are. We're not intending to do that, just protecting our listener. If you have network pingers that don't send any data, they just open, they bind to the socket for the listener and then immediately close again, they won't raise an alert, but if they try to send data, then they will. So we don't consider them a threat if they don't send any data. We have an interesting situation in Hursley where someone has mandated a port scanner on all of our testing boxes. And this port scanner sends data. So all of our testing boxes are getting this FTC with this bad data received. And our testing boxes are set up to always raise an alert that a test has failed if any FTCs were generated. Okay, but this one is working as designed. So we were about halfway through writing this line item and somebody said, you know what, we can use this to save ourselves from getting these FTCs. We'll stick our port scanner in there, because the thing is, they never asked us, the owners of these boxes, whether we wanted a port scanner on it. So we have put port scanner the IP addresses in this listener blocking list. They haven't come back to ask us why their port scanners are not getting any data anymore, so we'll see how long that takes. So it's a good test as well, it's a very good test. So we had a bit of fun with this as well. The next thing, if you're allowed through the firewall and you're allowed past the listener, is that there are a number of rules, both blocking and mapping rules at the channel level. So there are rules to block channels, rules to map channels to a particular MCA user, or rules to allow the channels through using the user ID that the channel already has. For example, the client asserted one, or the one on the MCA user in the channel definition. These rules will be applied before the security exit is run, and then a security exit, if defined, will be called, and it can have a go-to and decide that although the rules didn't have something to ban this particular connection, the security exit does. So the two can work in combination as you perhaps migrate from an existing security exit over to using the new rules. And then finally, after everything that might assign an MCA user has run, we will check against the final kind of rule, which is the user ID list, and that will also check for banned privileged users. So this final check is a list of user IDs that are not allowed to be used on this particular channel. And there's a special value, *MQAdmin, that can never be a real user ID. And this is taken to mean, on each platform, whichever set of users are the privileged users on that platform. Okay, so on Windows it's the MQM group, the administrators group, and the system user ID. On Unix it's the MQM group. On iSeries it's the QMQM group. On ZOS it's the Chinet and master user IDs. So, to save you having to remember all that, we've made a special value that says if this is somebody that has privileged access, then this will work on every platform to ban them. And then if you get through all of that, of course, then you've got your access control list that we talked about earlier, and the MCA user that has been assigned to that channel will then be checked against the access control list before that application can actually put any messages on your queue. Now, by default, this feature is on for brand new queue managers because we want to have the ability to persuade you to be secure out of the box as soon as possible. It is off on migrated queue managers because we don't want to cause an additional pain at migration, and we hope that maybe you already have security set up. There are 3 default rules that as soon as you do turn it on will apply. Those default rules are to ban privileged users, so using this *MQAdmin for all clients, to block anyone who tries to use a channel called system.anything. But another more specific rule to allow the system admin server.con, which is the Explorer channel. Even though we have opened up the Explorer channel, if you try to come across that client with a privileged user ID, you will be banned by the first one. So you still want to set up a non-privileged user, apply that to the Explorer channel, and then grant access, for example, using the role-based wizard to say you can at least look at things, for example. So those are the default rules that we have in place, which will be on for brand new queue managers, will be there but dormant until you switch it on for migrated queue managers. Yeah, you like that difference? So how do we configure these things? Well, we have MQSC, we have set channel auth commands, and we have PCF equivalents. And our rules have various pattern matching characteristics that are slightly new. Channel name and queue manager name as strings. You can put asterisks as wildcards in beginning, middle, or end, not just at the end. IP addresses, both IPv4 or IPv6, you can put an asterisk in any segment, so between the dots or the colons, and you can put a range in any segment, so number dash number. SSL peer name matching is as today, although we'll see later that there are a number of additional fields. And we'll show you some examples. Let's bring that up so that it's not quite so much of an eye test. So, this first rule is the one I call the backstop rule. So when you get to the point where you are doing everything with the channel auth, I imagine people having this rule that says, if I didn't match anything else, then I'll catch this rule and I'll block it. Now, something I didn't mention earlier in the week that occurred to me later is that also we have the ability to do a warning mode on anything that's blocked. So anything with user source no access. So setting the backstop rule up with warn yes will still allow people through. And if you stop getting any events that are matching this, you know you've caught everybody that's meant to come in. So that might be the way to start, is to set your backstop rule up with a warning mode on. Here's an example of a slightly contrived IP address to show you both parts of the pattern matching. 9.20.1-3. So anything that matches that pattern. So 9.20.1.1 would match that pattern. 9.20.4.1 would not. Okay. Here's another value in user source. This is user source channel, which says this rule allows the channel through with whatever's already on it. That means if it's a client, it's the flowed user ID if you have not set MCA user, and any other channels it's the MCA user that's set on the channel definition. So basically that says run it the way I had it before. Let it through with whatever it can. SSL peer name matching is the same as you're already used to with SSL peer name matching on channels. So this can do the same thing, but it means you can have many different rules for one channel, which you couldn't do with that one field on the channel. There's also perhaps an argument that says take the security control off the channel object and put it in place of the security administrator and leave the configuration stuff to the MQ administrator. Okay, so the MCA user on these rules will overlay what's on the channel, and you can have more complex peer name matching, so you can stop doing it on the channel too. So there's a separation of duty there as well. Here's a way to actually set an MCA user. So I now say user source map, and I provide an MCA user to be used, and that will override anything that was previously on the channel definition. We'll only use what's on the channel definition if you say user source channel. User source map is in fact the default, so you don't have to say user source map. That will be assumed if you don't say user source anything else. Here's another example that doesn't say user source map and also shows you that anything that you could put in the MCA user field in the channel definition of previous releases, you can put in the MCA user field for the channel auth rules. So if you're in a domain, you can have a fully domain qualified user, MCA user, to be set on that channel as well. And that's an example of mapping from client user. Also, you can make your mappings more restrictive. So here's an example where I have an SSL peer name matching on Morag Hughson, and I will assign MCA user Hughson, but only if this inbound connection is also coming from address 9 dot something. So that's even more restrictive. If I come in from another address, I'll probably match this one and not be given access. Okay? So you can restrict your rules further. So any rules that are not the IP address rule on its own can have the IP address added to the rule to make it more restrictive.
Right.
Yes.
There's a question in the lab about how the matching works when you have multiple matching rules and whether they went in, by order or specificity. So
Hold that thought for about 3 clicks. The blank bit in the bottom of the corner is what's going to talk about that. But first I'm going to show you the Explorer GUI wizard. So you can either use the commands or you can use new wizard. This wizard is something you can try out in the lab. So if you get the chance when you get home, it will walk you through the decisions you're trying to make in order to build this rule. Are we allowing somebody or blocking somebody, first of all? Which part of their identity do we want to use to do this rule? Is it peer name? Is it the IP address, remote queue manager name, etc.? And we'd say which channels is this going to apply to. And here you can put in a pattern. And it's not just an asterisk at the end. It can be in the middle, beginning, or at the end. And we have a button here that will take your pattern and show you which channels that pattern matches, that currently are defined at least. So you can see whether you've got your pattern correct before you move on. Then you can fill in your distinguished name pattern in this case, and if you want an optional IP address restrictor on that, you can go ahead and fill that in. And then you either say use the user ID that's already there, or map it to this particular user ID. And then on the summary page, we give you a human-readable description of what we think you just asked for. So you can read that and check that that's what you meant. And then we give you a command that is going to be applied. And this is a cut and pastable box that you can then take that out and put it into your script. So you can use it as a learning tool as well to build up your scripts until you get good at those. Yes, question?
Can I define multiple user mappings on one channel?
You can define as many different mappings as you want on one channel. So you can have SSL mappings, you can have remote queue manager mappings, all on the same channel. Or on the same channel pattern. So you might have system admin star and put several mappings on there. There's no limit to the number you can have.
What I just mean on this word is, could you define MCA users on basis of different SSL peers?
Yes. So you'd have two rules. You'd have one rule, well, you'd have multiple rules. If I see this distinguished name pattern, I'll give this MCA user. Then I make another rule that says a different distinguished name pattern. I'll give another different user ID, let's say. I could have several different distinguished names and different rules all mapping to the same MCA user, all on the same channel. So each rule is a distinct entity, and you can have multiple rules as long as they're not identical key. So if I say this channel, this SSL peer name, MCA user 1, and then I try to make a rule that says same channel, same distinguished name, MCA user 2, we will tell you you've already got a rule for that combination. You can't have another rule because we wouldn't know which one you meant. So they do have to be distinct in their key fields, which is the channel name, the type, and the identifying part of that type. Okay. So that's the wizard. If you have multiple rules, you may wonder, well, which one am I going to match? So imagine an inbound connection that is my.channel from this IP address with this distinguished name and asserting this client user ID. I could match one of these two rules. So which one is actually going to take effect? Well, we have to find a precedence order, as shown in this table. The SSL distinguished name is more specific in our eyes than, let's say, the IP address. You can have multiple different distinguished names coming from the same IP address. So the SSL distinguished name is more specific. And we've determined it is more specific than either the user ID or the queue manager name because it has more data in it, if you like. So in my case here, I'm going to match the SSL peer name one because it is more specific than the IP address one. Okay. Then if I have SSL peer name matching, there's lots of little attributes within an SSL peer name. Okay? And there's a precedence order needed for that as well. Let me show you why. Imagine I have a rule that says, okay, if I see organizational unit MQ development, I will use an MCA user of MQ user. If I see a location that's Hersley, then I will say her user. So if I come in with an inbound connection that has a certificate that says OU equals MQ development and location equals Hersley, which rule will I match? Because I could match both. I like to think of this as, well, there are many different organizational units in Hersley. There's MQ development, there's KICS development, there's the Java Technology Center, and so on. So the organizational unit is clearly more specific than the location. And that's indeed what we have. We have to find a precedent order like this, and organizational unit is more specific, so I will get MQ user as the MCA user to use. This is a much shorter list, actually, and I forgot to bring up the web page, but there are now a number of additional SSL peer name attributes that are allowed in peer name matching both on these rules and the original SSL peer name on the channel. And you will also see many more fields on your display channel status in version 7, including things like email, serial number, host name that it's come from in the certificate, those kinds of things. So there's many more extensions to that distinguished name now that we also recognize, display, and will match on. So, having had lots of rules that have different types, and you can match a different rule depending on precedent order, and now we have precedents within our SSL peer names as well, it might be difficult with hundreds of different rules to work out exactly what is going to match. Or indeed, if you have a channel that has come in and has been blocked and you get the error message, channel is blocked, it will tell you the various details that that inbound channel has in the error message, and you from there to work out why. So, here is the answer to the why, or what happens if. You can take those specific details and plug them into a special variant, the match run check variant of display channel, and it will return to you the rule that you matched. So if you've got a channel that came in and has failed, take that error message, cut and paste the parts of the identity that are in that error message, and you'll get back the rule that you matched, and presumably it will say no access if you got it from a channel with blocked error message. We think this particular match run check variant will be very useful for both learning what you have set up, servicing if you have no idea why you match. If I expect IBM service, first answer will be please run this command and find out why you were blocked. Testing to make sure you've got the right setup. We used it for our testing too. We very deliberately made sure that this command runs the same way as the channel does, so that it reflects as closely as possible the real behaviour when an actual inbound connection comes in. The one thing we cannot mimic is a security exit. So if the security exit comes in and blocks your channel, you'll have a different error message, channel ended by security exit, that we couldn't have predicted with match run check, because we can't interrogate the exit code. But apart from that, you should get the same behaviour as you do with your inbound channels out of this rule. So it's deliberately done so. It's very difficult otherwise to test all possible combinations of IP addresses and such like that you might get without having a massive network of different IP addresses to use. So we used it for some of our testing too. So that's channel authentication records, which of course, as with security exits, play in the identification for setting MCA users and the authentication process with link level security. Now the other most strong form of authentication we have is to use the secure sockets layer, which normally I would have a whole hour to talk to you about, but I suspect that somebody else will be coming in here and asking me to get out of the way. So we'll have a very quick recap. When you do SSL, you have digital certificates for authentication. You get hold of your digital certificate with your asymmetric key pair from whatever certificate provider you're going to use. Now there's a security wizard, an SSL wizard, which is support pack M004, which may help you with this because the commands to use for generate certificates are a little long-winded. The lab, if you have a go at it at home, allows you to play with this as well. You can also download it from the support pack site. It looks a little like this. It provides you with entry fields for various bits of information you need, like your queue manager names, hosts, channel names, cipherspec you're going to use, the fields you wish filled in on your certificates at either end. This is shortened for the purposes of demonstration. And it will ultimately give you back output like this, which you can then cut and paste into a terminal window in order to apply the commands instead of having to type them in 5 or 6 times before you actually get it right. Because they are rather long-winded commands, as you can see. That's a fairly short one, actually. You then, once having got these certificates from your CA, or you've self-signed them then from your file system, you put your certificates in a place that MQ can use, and that is your key repository. So SSL key R is an attribute on Alter Queue Manager, which points at your key database file or your ZOS keyring in that field. You then need to decide whether you want to have revocation checking, so an optional additional part of the SSL handshake. Once it's determined that the certificate is indeed valid, has been correctly signed and has not been tampered with, because that's part of the validation, you can have an additional check to say, okay, it's a valid certificate, but has it been subsequently revoked? The same way, let's say your credit card gets revoked when somebody's seen your PIN number and you phone up and say, stop it quick, right? So there is certificate revocation status checking, which either can be CRLs on an LDAP server, which is kind of the old way of doing things, or the industry now has invented a new way called OCSP, which is Online Certificate Status Protocol, which is an HTTP-based protocol for doing the same task effectively. LDAP is available on ZOS, OCSP is available on distributed now. We haven't yet got OCSP into System SSL for us to make use of. Then you might need to decide if you want to restrict the cipher specs that you can use. There are a couple of certifications available now. There's FIPS 140-2, which has been around on distributed for a while. It's now also available on ZOS in 7.1. And distributed have added a new one called Suite B, which is a similar kind of thing. It's a certification that has a small set of cipher specs that have been tested to a particular standard, particular certification, and you can say only use this set by turning these particular things on. Along with doing these things, we've of course got a pile of new cyberspecs, as with every release. And on distributed, we have moved up to TLS 1.2, which gives you SHA-2 algorithms, which a lot of you are very keen to have. This means the underlying GSKIP implementation is now GSKIP 8, for those of you interested in those things. And so there's a number of new cyberspecs. They're getting much longer and longer and longer, so I think I'm going to have to redo this foil to fit them in. I tried putting a new one in here, and it made it go into 2 lines, so I decided I'd stop. Final thing you then do is configure your channels to use SSL by choosing a cypherspec. So the actual key enabling parameter that actually says the channel will use SSL is the SSL siph parameter. You can do all the rest of that. If you never put SSL siph on a channel, nothing is going to use SSL. So that you can choose on a channel by channel basis. You can also decide whether you want to have your secret keys periodically reset. And this can be done either when a certain amount of data, reflected by this integer field, has been sent, or additionally, if the channel has been idle for some time because it's then sent a heartbeat, we'll also reset the secret keys there. If you wish to do peer name checking, you now have 2 places to do it. The old way was to put it on the channel. You had one pattern for the channel. The new way with channel authentication rules means you can have multiple different patterns, some allowing, some blocking for any one channel. And you determine whether you want to allow anonymity connecting into your server or whether you require all connections to provide a digital certificate before they're allowed to come in. So that's the whistle-stop tour of using SSL and new stuff in version 7.17. Okay. So access control also, of course, applies to channels. Access control controls putting to queues. Channels put messages to queues for you. They put messages to the target queue. The MCA user that you have set either through a security exit on the channel definition or with now a channel authentication rule could be used for that access control. Okay? By default, we use the channel's MCA user, the runtime MCA user. This may not be the same as the one that's in the channel definition. So a trick that T.Rob has been telling me to do for years is to set the channel definition to contain nobody. And so if the channel manages to come in through a route that does not have a security exit applying a valid user, or channel authentication record applying a valid user, it'll end up with nobody that can't do anything. So it's very important to understand the distinction between the user ID on the channel definition and the one that has been applied at runtime. And it's the one that has been applied at runtime, the effective user ID, if you like, that is used for your access control checking on your target queues. You can, alternatively, choose to use the user ID inside the message for access control. So each message that comes across the channel might have different access control. To do that, you say put authority context, and that will use the user ID inside the message. Now, to recap on something we mentioned about an hour ago, this might be a user ID from a different system that is not understood by the target system. So that is something to be aware of if you do use put authority context. Having sorted that out, it's then normal MQ access control. Does this user ID have access to put these messages to this particular target queue? And if they can't, those failed puts will end up on the dead letter queue. If they can, all's well. There's a couple of other funny looking ones here. Only MCA and Alt MCA. On ZOS, you have dual user ID checking to use. You check the MCA user and also what we call the channel user, which is either the flowed SNA user, the mapped SSL user using a CNF mapping, or ultimately the CHIN user ID. And if you want to go down to single user ID checking as opposed to dual user ID checking, then these two equivalents are available for you too. Talking of dead letter queues, it is worth making sure that the put access for the dead letter queue is not too restrictive. Because if your channel is unable to put the message it has failed to put to a target queue onto the dead letter queue, then that channel is going to have to stop, if that's a persistent message, in order to save that message on the transmission queue at the far end and not throw it away. On the other hand, you want to make sure that the getters from the dead letter queue are restricted so that the dead letter handler is the thing doing that. Be aware with your dead letter handler that you don't simply retry the failed put that failed for security reasons under the authority of the dead letter handler, which then succeeds, because then you've just stepped around your security. Something that might be interesting to you, since we're talking about dead letter queues, although it's not necessarily security related, is that 7.1 has a new field on channels and on topics to say whether to use the dead letter queue for this particular channel. So there's an attribute called useDLQ with values yes and no. If it's valued yes, which is there by default, it will attempt to use the dead letter queue defined by the system. If that's not there, of course it can't use it, business as usual as you have today. If it's useDLQ no, and regardless of whether you have set a dead queue, that channel or that user of that topic will not attempt to use the dead letter queue. And we'll go straight to the next step in failure processing, which in the channel's case would be to roll back and wait for you to fix it. Okay, so confidentiality, secure sockets layer also applies to these services as well. You get encryption across your channel. You've chosen a cipherspec. That cipherspec gives you your encryption algorithm and your data integrity function. So secure sockets layer gives you both confidentiality and data integrity as well as authentication. You can also write an exit to do confidentiality, data integrity type things. The message exit is one of the exit points you may use for that. You could also use send and receive exits to apply encryption services as well. I expect less people do this sort of thing now that SSL is built in, but the facility is still there if you want, for example, to do partial encryption rather than encrypting everything that goes over the channel. So, it's quite a big summary actually, but OS user IDs, we see them in context, we can set them with channel authentication records or security exits. We can authenticate with our OS logon for user IDs that are local bindings applications. CONNX, we can supply user ID and password, and we can do some authentication with security exits, channel authentication records, or strong authentication with your SSL facilities. You have command security and API security for access control. Put authority on your channels allows you to control which user IDs are used. And also remember your firewall is part of your access control protection, right? Making sure that some things can't even get as far as MQ. You have auditing facilities. You have facilities to provide you with confidentiality. Something we haven't talked about, but I've put in at the very last minute, is something else new in 7.1, and that is that API exits are now available on clients as well. Now, API exits are a means by which to apply facilities such as confidentiality at the application level before it leaves the application process. So having API exits also in clients will come in very handy for that kind of thing too. Application level security gives you data integrity, and secure sockets layer, of course, gives you data integrity too. So you are here. We're almost done for the week. I don't think there's an MQ session next. There's a message broker session in the next slot. But that's me done for the week. I'm very glad that you all came to the conference, came to listen to us. I hope you had a good time. If you have any more questions, please ask them. Yes?
We did mention the lab and download for scripts and stuff, but we didn't mention that the GA date is in. Do you recall what the GA date is? Because the lab that's published and posted to the website actually won't work with the version of MQ that everyone has access to.
Yeah. So the GA date is November
14th, I think?
Yeah, I was going to say the 11th, but it's somewhere about there. So mid-November, you should be able to get hold of at least a trial edition and have a play with the lab. So yeah, don't rush home and try and go and do the lab, on Saturday, because you won't have a level of MQ yet to be able to use it. But come mid-November, when the code gets released from Harzy, then you can go grab it and have the play and use the scripts and the instructions. Thanks for the reminder. Yes. And I'm always told to remind you to please fill out a session evaluation form as well, so I hope you should do that. Thank you for your attention.